Hi, hello everybody. So this is the video dealing with section 5.4, product to sum and sum to product formulas. And this is our second part of the section 5.4, where we go from the sum expression to a product. Okay, so this is the reverse from before, right? So before we had, product of sine, cosine, 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 sine, sine, or cosine times sine. And we went into a sum or difference expression, and now this is the reverse, where we have sum or different between sine and cosine, or sine, sine, cosine, cosine, and we got an expression involving a product. Okay, again, this is mainly to simplify expressions or solve equations, and all we have to do is to apply one of the formulas to the expression that we have and find out what the answer is. So for example, again, you don't have to memorize these formulas. First example, I have sum of two sines. Just pick the formula that fits your circumstance. That would be the first one. In this case, I have the difference of two cosines. I would use the last formula. Okay? And the same would apply for the other two. Okay, so if I have the difference of two sines, would be the second. If I have the sum of two cosines, it would be the third. All right. All right, so let's do sine 9x plus sine 5x. Now, and let me just say, even before we start, to remind you what we did before, okay? When you have 9x and you're adding 5x, we obviously get, right, 14x. Sine 9x plus sine 5x is not sine of 14x. If this was the case, we wouldn't need all of these formulas, right? So don't think it's the same. It's not the same. And again, if you want to, I'm not going to do it here. You can do sine 9x plus sine 5x and check to see if this is sine of 14x, and you can let x equals 30 degrees. Okay? You can check that. It's not the same. All right? So we're not adding the angles. The angles don't get added. The sine function gets added. All right, so don't make that mistake, okay? All right, so look, sine 9x, sine 5x, I'm going to use the first formula, as you can see up there. All right, so here we go. This is the formula. 2 sine alpha plus beta. So 9x is my alpha, 5x is my beta. So 9x plus 5x is obviously 14x. And notice the 2 is dividing the angle, not the function. Okay, so it's only here. All right, so again, notice that sine 14x over 2 is not the same as sine 14x everything over 2, right? So please understand that these two things are different. In this case, I'm only dividing the angle. In this case, in the second case, I'm dividing the whole sine 14x, right? Not the same. Times cosine of the difference, alpha minus beta. So 9x minus 5x, 4x, and again over 2. All right, so we've gotten to this part so far. Here's another thing for you to observe, not to make an algebraic mistake. Take a look at this. I'm going to write it over here. Okay. This number does not simplify with that number. Okay. The 2 is dividing the angle. So you cannot do this. You cannot simplify these two. However, look at this case. If I had something like this, sine 14x, everything over 2. Now this can simplify with that. That is fine. Okay, because the 2 is dividing the entire fraction. So don't make that mistake. There would be an algebraic error. All right. All right. So we've mentioned the two possible cases to avoid you making a mistake. So now, okay, I can definitely simplify the angle. 14 and 2 is 7. So this is going to be 2 sine 7x times cosine 2x. And again, it may seem like this is not very helpful or doesn't make it any clearer or simpler, but for the purposes of a individual application, this may be better. Okay, so sine 9x plus sine 5x is exactly this in product form. So this is my A problem. B. Cosine 4x minus cosine 3x. So obviously I choose the correct one, which is the last one, the cosine of a difference, right? Or a difference of two cosines, where 4x is my alpha, 3x is my beta. And I'm going to apply this formula. So minus 2 sine of alpha plus beta over 2. So alpha, oh, no, not here. Careful, I'm making a mistake here. Right? So here is my alpha 4x plus 3x, right? So 7x over 2 times sine alpha minus beta, so 4x minus 3x, which is just x over 2. Okay, so this one I cannot simplify anything, so I just write the final answer. Sine 7x over 2 sine x over 2. Okay, and that's it. I am done for both cases. Right? So we went from a sum or difference and we turned it into a product. That's all we have to do. We pick the correct expression and we simplify. Okay, now I am going to show you another example. And this is a very good example in showing you the reason why we use these formulas and how using them will allow us to simplify an expression that may seem very complicated into something extremely easier. So this is a good example from your textbook. Yeah, you can always look in there for all of the details and steps, but I'm going to go over in here. So the question is verify the identity, and we have this very complicated identity, and we need to verify that this is equal to tangent for any angle x. And it seems almost impossible that cosine 3x minus cosine 5x over sine 3x plus sine 5x is equal to tangent, but we are going to show you that it is. So I am going to apply here, numerator and denominator, the sum to product formulas and see if we can simplify along the way. So on the numerator, I have cosine 3x minus cosine 5x, which is the last formula. Okay? I'm not going to work on the right side, just on the left. So my alpha would be my 3x. My beta would be my 5x for the numerator. So I'm going to apply this formula. So minus 2 sine of the alpha plus beta. So 3x plus 5x is 8x over 2. 8x over 2 times sine of the difference, alpha minus beta. So 3x minus 5x minus 2x over 2. Everything over, and now I'm going to do the same thing with the denominator. Okay? So for the denominator, I have sine plus sine, which is the first formula again, where my 3x is my alpha and my 5x is my beta. So I'm going to apply this formula. So 2 sine of the different, I'm sorry, of the sum. All right, so 3x plus 5x is 8x again over 2 times cosine of the difference. All right, so it's cosine of 3x minus 5x over 2. Okay. Now I go around simplifying things. So the 8x over 2 is obviously 4x. This is obviously minus x. This is obviously 4x, and this is obviously minus x. So my second round would be minus 2. I guess the minus 2 cancels with this 2. So I have minus 1. And I have times sine of 4x times sine of minus x. And the denominator, I have sine 4x times cosine of minus x. Okay. All right. So the sine 4x and sine 4x is out. And I have minus sine of minus x and cosine of minus x. So now remember what I told you, we can't have this minus in here. So I have to evaluate what each of these things are. Okay. Now the sine of minus x we already discussed, right? So this is the sine axis. If this is a positive angle, the minus x would be a negative sign. So this is sine is greater than 0, and here is negative. So sine of minus x, sine of minus x, this expression right here is minus sine of x. Okay, so this minus is already there. So minus sine of x over. Now let's take a look at what this is. Now the cosine is the x-axis. So here is an angle, x, okay? Minus x would be right here. But what is the cosine? I'll make it bigger because I don't think you can see this. See if I can make it bigger. It's very difficult in here. So let's say that this is my angle x. The cosine of it would be, okay, let me just, the cosine would be this line, this blue line right here. So for a negative x, here's the angle negative x, okay? The cosine would be the exact same segment right here because this is the x-axis. Okay, this is the x-axis, which is the cosine x. So for positive and negative angles, the cosine is the same value. And you can check this on the calculator. We're not going to do it now for expediency. Well, I guess I can show you. Let's check. Let's assume the x is 30 degrees. So let's find out what cosine of 30 degrees is. And then you're going to see that the cosine of negative 30 degrees has the same value. Okay, that's the exact same thing. So let's check this on the calculator. All right, so I'm going to do cosine of 30 degrees. So it's 0.8660. Now let's do cosine of minus 30 degrees. And this answer should be exactly the same. Okay, according to my picture here, I can't move the calculator. Okay, and that should be the exact same positive value, 8660. And there you go. You can see that it's the exact same value, 8660. And the reason being is because the x-axis is my cosine. So 8660. So cosine of minus x is just cosine of x. Okay, so on the numerator now, the two minuses cancel, becomes a positive. And what is sine over cosine? Well, that's one of the trigonometric identities, which is tangent x, which is exactly what we expected to get. All right. So it is important to see, again, the reason for these sum to product and product to sum formulas is to simplify. Look how complicated this expression is. This is incredibly complicated. To do anything, to evaluate, to simplify, to solve an equation. But if we apply the product to sum to product formulas, I get just tangent, and tangent is much, much, much simpler to work with. Okay, so this is the reason why we covered this topic, either sum to product or product to sum formulas when dealing with these trigonometric equations.